Okay, hello guys. We are going to do section 8-6 today, which is called choosing a factoring method. We're going to take everything that we've done the past couple days and what we did before spring break, and we're going to combine it all into one lesson. So we're going to have a mixed variety of problems, and we're going to take the problems just a step further today than we usually do. So you're going to want to write down all these examples that I say, and really make sure that you understand them as you go along. Don't just watch the video just to check it off your list. Okay, you really need to understand these. So let's get started. The objectives for this lesson are to decide which method of factoring you're going to use, which method would be appropriate for the given problem, and then we're going to be combining several of the methods, like I said, into one problem today. Now keep in mind that a polynomial is only fully factored when the product is written out and nothing further can be factored. It has to be in simplest terms, okay? So just think of a fraction being simplified. You can simplify a fraction a little bit and it still not be fully simplified because you can take it further. Same thing goes for factoring. Okay, you can factor something, but then it's possible that once you factor it, it can be factored again or simplified further. So that's what we're going to be doing today. Okay, so in these first couple problems, we're just going to simply decide if the problem can be factored any more than what is already done. Okay, so we had this problem, 3x squared times 6x minus 4. It looks like potentially it may be factored as much as possible. But when you look at this right here, 6x minus 4, you notice that there is a factor of 6 and 4 in common. And that factor would be 2. So what I need to do is imagine that the 3x squared wasn't even in the problem. And I'm going to just look at the 6x minus 4 and take out the greatest common factor between those two things, which is a 2. Okay? So I'm going to take out this 2. And what's left after I take out a 2 would be my 3x minus 2. Okay? But this 3x squared is definitely still a part of my problem. Okay, so all we did was take out the greatest common factor. Okay, now what I see I can do is I can multiply these two things together. This is just multiplication. 3x squared times 2 gives me 6x squared. And then this 3x minus 2 cannot be simplified anymore. That is in its simplest terms. Okay, now I don't want to multiply this stuff together or, that's not really factoring. Okay, so this is going to be our final answer. Okay, all right, let's look at this one. X squared plus 1 times x minus 5. Well, I can definitely tell that this x minus 5 is for sure in its simplest terms. There's no way that could go any simpler. But this x squared plus 1, you may think potentially I could try and factor that. Okay, but x squared plus 1 is different than x squared minus 1. X squared minus 1 could be factored, okay, because of the minus. But since this is x squared plus 1, I can try and factor this all that I want. I can try and do x plus 1 times x minus 1. I can try x plus 1 times x plus 1. And I would see that simply none of those are going to work, okay? None of them would give me what I want. So this is completely factored, okay? There's nothing else that we can do here to factor this. So my answer is simply the problem. Okay, I'm going to just rewrite it. That's as factored as it can get. Okay? All right, let's look at these two. Same thing. Let's see if we can factor these any. Okay, I have 4x plus 4 and x plus 1 being multiplied together. Well, when I look at this 4x plus 4, I see that both terms contain a 4. So I know that I can take out the greatest common factor between 4x and 4, which is a 4. So I'm going to take out the greatest common factor, 4, and I'm going to see what I'm left with. 4x divided by 4 is x. 4 divided by 4 is 1. So that's how I can factor that first binomial. The second binomial cannot be factored. X plus 1 is in simplest terms. Now I notice that I have two x plus 1s. Okay, so another way I can rewrite this would be 4 and x plus 1, that quantity squared. Okay, either answer, this one or the one right above it, would be acceptable. But the one I just boxed would probably be the best. Okay, now if I look at the next problem, 5x squared. Okay, there's nothing I can do to the 5x squared. X minus 1, that is also in simplest terms already. If it was x squared minus 1, that would be a different story, but it's not. It's x minus 1. So this one is also completely factored. So the answer is simply my problem. You cannot factor it. There, it's already as factored as it needs to be. Okay, so this slide right here kind of outlines for you the different steps that you can take when factoring polynomials. It tells you, step 1, you always want to look and see, is there a greatest common factor that I can take out? If so, you always want to factor that out first. Then you want to check to see if you maybe are left with a difference of squares or a perfect square trinomial. That's like what we did yesterday with the factoring special products. You want to look and see, could I potentially have one of those? If not, you just would proceed to factor like I initially taught you how, using the x and then the tx if that's needed. And then once you think you're finished, you always want to take a look back at your answer and just make sure that there's no other common factors that you could possibly factor out of your answer. So this would be a great place to pause the video, maybe write down some of these steps so you don't get confused and you know where you're going when we move on to this problem right here. Here, I've given you the problem 10x squared plus 48x plus 32. Okay, and it asks us to factor this completely. Okay, well, step number 1 tells us to check for greatest common factor. So I'm going to look at the 10, the 48, and the 32. And I'm going to see what is the greatest factor that they all have in common. Well, that would just be a 2. So I'm going to factor out a 2 from each term. 10x squared divided by 2 leaves me 5x squared. 48x divided by 2 leaves me 24x. And 32 divided by 2 leaves me 16. Okay, so that's all I've done so far is take out my greatest common factor. Now I want to look at this part right here that remains, and I want to ask myself, can that part be factored anymore? Okay, sometimes it will be able to, sometimes it won't be able to. So what you need to do is you need to try it. So first thing I'm going to do is I'm going to start by making my x, and I'm going to say 5 times 16, that gives me 80. My middle term 24 is going to go down there. Now what times what gives me 80 that adds to give me 24? That one might take you a little bit to come up with. 4 and 20. Okay, now I see that I need to make a t because this number right here is a 5 and not a 1. So I start with 5x, 4, 20. Now I'm just going to simplify this. 5x and 4 doesn't simplify any, but 5x and 20 definitely does. 2x and 4. Okay, so now I'm going to write out my answer. My answer, I cannot forget to include this 2 back in my answer. It is part of my answer, guys. Don't leave that out, or you would get the wrong answer. So there is my answer. Now, how can I check that? I can check that by foiling. Okay, I can FOIL my 2 binomials together and then distribute in a 2, and I should get what I started with, my problem up there. Okay, so we get 5x squared plus 20x plus 4x plus 16, and I'm going to multiply all of that by 2. I can combine those like terms first if I want, or you can combine them at the end. I get 10x squared plus 40x plus 8x plus 32. Now I know 40x plus 8x gives me 48x, so I got what I started with. So I know I am good to go. And nothing, then I always want to look at my answer, nothing here And 2 times 5x plus 4 times x plus 4 can be simplified anymore, so we are finished. Okay, here's this one. I start with 8x to the 6th y squared minus 18x squared y squared. First thing I want to check for is our what? Greatest common factor. So let's look at the 8 and the 18. What do those have in common? Well, again, those have a 2 in common. So I'm going to factor out a 2. But now I have some variables here that I need to look at. I have an x and a y. I want to see, do both of my terms here have any of those in common? Okay, well, this one has 6 x's, an x to the 6th, and this one has x squared. So they both have at least 2 x's. So I'm going to take both of those out. Remember, we've done this before spring break, so if you need to, you can look back to that lesson and see how we did this. Then I want to look at my y's. I have 3 y's, oh, I'm sorry, 2 y's and 2 y's. I underlined it 3 times. So y squared and y squared, they both have a y squared in common, so I'm going to take that part out as well. Now in parentheses, I get what's left after I take out a 2x squared y squared. Okay, so what you can do is you can think of this as dividing 8x to the 6th y squared divided by 2x squared y squared. Let's see what we get. 8 divided by 2 is 4. X to the 6th divided by x squared. Remember, this is division, so we subtract exponents, we get x to the 4th. Y squared divided by y squared is just 1. So we get 4x to the 4th there, and now I'm going to do 18x squared y squared divided by 2x squared y squared. 18 divided by 2 is 9, and I notice this negative sign. So minus 9. X squared divided by x squared is 1. Y squared divided by y squared is 1. So those all go away. So that's all I have. Now, I need to look and see is what I was left with after I took out my greatest common factor. Can I take that any further? Okay, so take a good look at it and see what you think. Okay, well, if we did our homework last night, we probably can tell by now that this is a perfect square just like this is. Okay, so this is an example of a perfect square trinomial. Remember that middle term would be a 0x. Okay, so this can be factored. How? Let's see. I'm going to have 2 binomials. I need to think, what does this first term have to be so that when I FOIL, I would end up with a 4x to the 4th. It would have to be 2x squared and 2x squared. Now, what's the square root of 9? 3. But I need that middle term to go away. That means I need 1 positive 3 and 1 negative 3. Okay, now what can I not forget? I can't forget to include that in my answer. My greatest common factor is a part of the answer for sure. So it has to be included. Okay, now I want to take a look at what I have. I want to see if anything else can be factored. 2x squared plus 3 and 2x squared minus 3, those can't go any further than what they already are. So we are finished. Okay, moving on to this one. We have 4x to the 3rd plus 16x squared plus 16x. So where do we always start? We should be catching on by now with our greatest common factor. Okay, so what do a 4, a 16, and a 16 have in common? Definitely a 4. Now let's look at the variables. I have x to the 3rd, x squared, and x. They all have at least what? At least one x. So I'm going to take out one x, and now I'm going to see what's left. 4x to the 3rd divided by 4x, that leaves me x squared. 16x squared divided by 4x leaves me a positive 4x. And 16x divided by 4x leaves me a positive 4. Okay, now I want to take a look at what was left in my parentheses here. X squared plus 4x plus 4. And I want to see, can that be factored anymore? Okay, so let's see. If I make my x here, I know I need 4 here, 4 here. What times what multiplies to give me 4 but adds to give me 4? 2 and 2. I don't need to make a t because this number right here is a 1. So this factors into x plus 2 times x plus 2. I put my greatest common factor at the beginning, and I'm finished. The only thing I can do here is, since I have 2 x plus 2's, I can write that as x plus 2 quantity squared. And that would be my final answer. Okay, keep hanging on. We're almost finished. A couple more examples. Let's see what we get here. 2x squared y minus 2y to the third. What's our greatest common factor? 2. 2 and what else? Also a y. Good. I can't have an x because the second term doesn't have an x. Okay, so let's see what's left. I've got one y out here as my greatest common factor and one y right here. So my y's are taken care of. My 2 is taken care of here, but I need an x squared. Then when I look at the second term, I've already got my 2. I've got one y here, but I need 3, so this needs to be minus y squared. Okay, now I want to look at what's in my parentheses, and I want to decide, can this be factored? Ooh, I see what we did yesterday. This is a perfect square. This is a perfect square. I have a difference of 2 squares. That can definitely be factored. My middle term would be that 0xy. So that tells me I'm going to need opposite signs. What times what gives me this x squared? Well, that would have to be an x times an x. Okay, and then I want to think, what's going to give me this y squared? That would be a y and a y. Put my greatest common factor at the beginning, and we're finished. Because I look at my answer, I see that nothing else can be simplified. That's as simple as it gets. So we're finished. Okay, we've got 2 on this page. Let's see what we can do. I look at 9x squared plus 3x minus 2. First, check for greatest common factor. Is there anything that a 9, a 3, and a 2 have in common? No. Nothing that's in common. Do they have any variables in common? No. So that tells me I'm going to factor this just like normal, using my x and my t. So pause the video here. Work this out yourself. We should be pros at this by now. And then press play when you've got your answer. Okay. Once you've pressed play, you should see that this is the answer you should get. This cannot be simplified anymore. So that problem was just like what we've been doing. Okay, now I'm going to look at this problem, 2p to the 5th, 10p to the 4th, 12p to the 3rd. And I'm going to see, first of all, greatest common factor between 2, 10, and 12. That would definitely be 2. What do p to the 5th, p to the 4th, and p to the 3rd have in common? They have a p to the 3rd in common. So that's the most that I can take out from all 3 terms. I'm going to see what I'm left with. And 2p to the 5th, remember, think of this as 2p to the 5th divided by 2p to the 3rd. That leaves me p squared. Then I'm left with 5p minus 6. Okay, I want to take a look, see if this can be factored. I need to make my x. I know that this needs to be a negative 6. This needs to be a 5. So I stop and think, and this is going to have to be 6 and negative 1. When I write out my 2 binomials, I get p plus 6, p minus 1. I need to put my greatest common factor at the front. I look to see, can this be simplified anymore? Nope. Can this? Nope. Can this? Nope. So we are finished. Last problem. X to the 4th minus x squared. Okay. Greatest common factor. There's not a number that's the greatest common factor, but there is in fact a variable. They each term here has an x squared that I could take out. So I'm going to take out my greatest common factor, which is x squared, and I see that I'm left with x squared minus 1. Okay, hopefully we're starting to see this trend as well now. This is a difference of squares. This is a perfect square. This is a perfect square. This is subtraction. So that tells me I can factor this into x. I need my middle term to be a 0, so this should be a plus sign. This should be a minus sign. The square root of 1 is just 1. So I have x plus 1, x minus 1. My greatest common factor goes at the front. I see if there's anything else that I can simplify. The answer is no. So we are finished. That is fully factored. Okay? Stop, take a look back at all these examples that we've done together. Replay something if you don't understand something, if I went too fast. There's more examples in the textbook if you need to go there. If not, you're ready to start on your homework, which is page 569 out of the textbooks. The numbers are on the board, and I will help you guys if you need help.